Alright, good day everyone. Welcome to HYSYS Academy. Alright, so today we are going to be doing distillation of crude oil. In this video, I'm trying to perform oil characterization first before we now go into the distillation of crude oil. Now, this particular training is going to be a bit different because of we are going to be showing you how to get some of these parameters from online sources. Alright, so we're going to be working with a literature review on this particular topic. Alright, so what we want you to do is just you can learn how to do this on your own. Alright, so in case you're trying to perform some simulations and then you're thinking of where you can get data from, now this is something you can easily just go online and then check for literature review, research work on this, and then you'll be able to get something for the process you're going to be working with. Alright, what we have here is from ResearchGate, and then this is crude oil distillation. Alright, using Aspen HYSYS. That's where we're going to be getting the data from. Alright, so going forward, um, alright, let me move this. I already have my simulation open already. Okay, so we can see crude oil distillation using Aspen HYSYS from ResearchGate. Alright, the next thing we can see the author is Jesse. Okay, now it's advisable to always try and read through your literature review so you can get to understand the concept better. Alright, now we're just going to go down to the assay installation. We have the assay data. Alright, this is from Bashra Light. We have two assay data here, the light and then the medium. Alright, this the light and then the second one is the medium. In order to start this process now, we need to um, get the components. So we're going to be selecting this light end component here. Alright, and at the end of the day, what we're going to be producing is going to be kerosene, AGO, and diesel. Alright, naphtha 2 is going to be part of it too. So um, yeah, that's the major thing we're going to be producing. Then another thing is this video is going to be of two parts. The first one is just going to be talking about the oil characterization as well as the setup before the distillation process. Then the second one will be about the distillation of the crude oil. Alright, so let's start. Okay, so I'm going to be selecting all these C1 to C5 and then cyclopentane, benzene, and water. Alright, so let me get that C1 to NC5. We have the cyclopentane, benzene, and water. Okay, alright, fluid package pengromycin. Alright, then we go to oil manager. We're going to add the input assay and then click on add assay. Now remember, we're having two assay data types, so we're going to be doing this twice. Okay, so for the first one, this is the light crude. So now we have the IBP. The BP stands for the boiling point. We have the temperature of C, that's Celsius. We have Fahrenheit here. We have, now this is in weight percent. All right, so WT weight percent. We have the IBP weight percent, that's the percentage, the mid-range, and then we have the density, which is in kilogram per liter, and then we have the density in pounds per cubic feet. All right, we also have the sulfur content. All right, so all of this we are going to be adding it into the assay. Then we have the light ends. All right, so the light ends, in order, okay, that's what we selected. I'm going to make use of that. So to continue, we have the bulk property. Yes, this was given. Alright, this particular one was given. You can see um, crude API 33.5. Alright, okay, and then we have the sulfur content. So these are the bulk properties. Alright, then bulk properties, we have TBP. Okay, this is dependent. Sorry, we don't have this, so we're not using it. We have the density curve, which is going to be independent. Light ends, yes, we have to impute composition for that. Alright, so remember we're working with mass. Alright, so everything we're going to be doing here, the basis is going to be in mass. So now the assay, right, like to split this up. So that we can have room. Okay. Okay, so we click on edit assay for distillation, and then we are going to make use of the IBP here and the temperature in Celsius. So the mid-rate IBP is 6.1. Okay, another thing, we need to add the other points. So we have 1 2 3 4 5 6 7 8 9 10. So we're going to make this 9 because we already have one added initially. So now I can start 6.1, 13.55, 18.1, okay. Temperature, making use of all of this. So all right, click on OK. You will see to tell you table is ready. All right, so the next thing we're going to is the density. Okay, all right, going to the density, click on add. Now for the density, we're going to make use of the LB cubic feet, so that's pound per cubic feet, and then we're making use of the mid-range. While making use of the mid-range, we have the midpoint based. All right, so that's why I'm making use of the mid-range. So all right, for these two, we need to add extra 9 points. Okay. Okay. Now for the density, just going to be copying it and pasting it. So, all right. Okay. So this is ready. Now we go to light end. Okay. So 0.01. All right. Then change this to mass percent. Always confirm that. Make sure that you're working with the right bases. Okay. Then the bulk property API 33.5 was given, which is the density. So I'm going to making use of 33.5, and then we change the units to API 60. Okay. Now we still have the sulfur to add to it. Now we don't have a sulfur content here. Now if there was no sulfur content, I could just quickly click on calculate, and then it will give me a blend, alright? But the acid will be calculated properly, but we have the sulfur content, so we have to add it to it, and then there's no room for sulfur content right here. So what we just need to do, we will go to user property. We need to define this. That's why we have the user property. We add a new property to it. Now for this property, we are going to change the basis to mass fraction. Remember, everything we're working with here is in mass basis. Alright, so we're going to change this to 0. Lower limit, upper limit, you can just keep it at 100. Now we don't have any of this, so we can just make them all 0, or you could even leave them empty, anyone. I'll do the empty for the next one. Okay, then we come to, okay, I need to change this. Let me just change this to sulfur. So now I need to select what, okay. Sulfur 1. Now I go back and I go to user curve. See the user property we just added. It's here already. Then I click on add. Now I'm going to change this to, it's supposed to be independent. Keep it on independent. The bulk property given for this is 2.85. So we just put 2.85 here. All right. I'm going to change this to independent. Why? Because we're making use of the mid-range, and I just want to have all of this set up, and then can copy what I want from it and go back. So okay, copy it. All right, before I continue, let me save this. Just see oil characterization. Okay. All right. Now I can change. Oh, now I have to change this back to independent. Yeah. Now I can change it. Paste. So all I just need to do now is to add the sulfur content to it. So yeah. I'm going to be adding all of this. So that's 0.002. Okay. Okay, so this is ready. Now I can calculate my blend, my HYSYS, sorry. Just go back to, so I click on calculate. As it was calculated, I just need to do the same thing for the second one. All right, used light and yes, density curve independent. Change this to mass. All right. So let's start with the distillation. So just to confirm, this is for the light. Now we're going to the medium. Now you can see the temperature for the medium and the temperature for the light are kind of the same. So I'm just going to copy that of the light end and bring it to the temperature part of this. So but before I do that, I need to add 9 more points to this. Okay, now I can do what I want to do. Temperature, paste. Oh, did I copy the right temperature? No, I copied the wrong one. So let me do that again. Copy the wrong thing. All right. Okay. Now for the mid-range is different, so I'm just going to add the new mid-range to this point here. So having 6.2, 13.8, Alright, click on OK. So that is ready. The next thing is my density. So I'm just going to add this one. Alright, so percentage, we have 10. Okay, so for the density, I'm just going to copy and paste like we did the last time. Alright, so click on OK. Light end. Alright, and then we change this to mass percent. Remember, always keep your mass percent as the basis of this oil characterization. From here, we go to the bulk properties, and then we can see that for the bulk property here, the API is 29, so under mass density 29.1, change it to API 60. Alright, so after doing that, we need to add the sulfur to it, so let's add our sulfur content. Okay, just like before, 0, 100. Let me open it up so you see. Lower limit 0, upper limit 100. Need to trying to change the name. So okay. So for 2, remember this has to be mass fraction. I think I forgot to do that. Let me confirm that everything is as it should be. Alright, so we're good to go. So going forward, I just go to assay under curves, add sulfur 2. The bulk property for this is giving us 3.05. Alright, so I'm going to make this dependent because I want to copy my mid-range from the density. And then I'm changing it back to independent so I can change it. Alright, so now what I'm just going to do now is to add okay. Alright, so I'm going to be adding the sulfur content. So we have okay. So now we just go back and calculate the blend. Yeah, so everything has been added. Calculate. Now we have our blend calculated. Now what we need to do is to create an output blend. Now you're creating the output blend because of you need it to show on your Aspen simulation. That's the HYSYS simulation page. So I'm going to be adding this and this. Okay. Now for this part we need to add the flow rates to it, and then according to, let me get back. Alright, so for the blend now, according to what we have here, if you read through the work and then you come to this point here, they're trying to produce at I think 100 million barrels per day or per year. Yeah, 100 million barrels. Okay, by the end of 2045. All right, that is about 88 barrels per day. All right, that's what they're trying to get per day, 88,000 barrels per day. So they splitted the two of them. The light end is 70% and then the total volume of the medium is 30%. So the volumetric flow rate for the light end is going to be at 61,600 barrels per day. So remember the first one is the light end, so we just make this 61,600, change this to barrels per day. Yes, to convert it back to kilogram per hour, if I'm not mistaken. Alright, then the other one is 26,400, so put 26,400, so I converted it back to cubic meter per hour. So we have barrel per day. Okay, so now let me change this unit so that we can be working with barrel per day. In order to do that, go to options, unit of measures, under standard liquid volume flow, I just change this to barrel per day, and then okay, liquid volume flow, let's still change that. Okay, barrels per day. Okay, all right, so I've been able to convert this to barrels per day. We leave it on auto cut, leave everything the way they are, and then we click on install oil. Now it can give us as blend 1, blend 2, blend 1 AC1, blend 1 AC2, but you know it's a combination of the both of them, and the blend 1 is a combination of both. So we're going to close all of this and then just have the blend 1. Now this was going to show in, let me say, crude oil blend, and I click on install. Alright, so let me just change the name of the assay so we can lights assay. Just want to change the name. I will name this medium. That's it. Alright, now we can go to the simulation environment, and then at this point we see we have the crude oil blend. Alright, so let me just reduce this. Now we work with the process that is given. So alright, so I'm going to work with the process that was given, and then let me split the screen back. Alright, so we have that the blend, after blending everything, we can see that the blend has temperature. Okay, the blend oil is 77 Fahrenheit, and then the pressure is 261.1 psi. So in order to do that, I come here, I change this, my temperature, to 77 Fahrenheit, and then 261 psi. Okay, now I need to make sure that this is, my solver is active, so change my solver to active, and then all of this is ready. So now we need to work on the next thing, which is the preheating. So the blend, or as the oil is preheated first. The conditions for our preheater, we have the preheater at 280 Fahrenheit, and then the pressure drop, they say there's a low pressure drop, so I'm going to be adding the heater to it. Okay, I'll call this preheat 1, preheater 1. Okay, my inlet is the crude oil blend. Energy stream, I'm just going to name this E1Q. Alright, my outlets, I'll call this warm blend. Alright, now we need to add the specification. Now we said the temperature that should be coming out from this point is about, alright, preheated to 280, so put 280 Fahrenheit with low pressure drop. So I'm just going to say maybe there was a pressure drop of minus 20 kPa, so I'm just going to do 7980. Okay, the next thing from here is the desalting. Now the desalting is to, remove solid particles. All right, organic, so inorganic salts and some other solid particles from it. So we are going to be doing that with water. So I'm just going to be adding the mixer to it. Remember, warm blend. Second stream is going to be water, and then the output blend is going to be wet, let's say wet crude oil, or let's say wet blend, let's say wet blend, since we wet warm blend actually. Okay, now we just need to add the specifications for the water, and then this will be solved. Yeah, I need to delete this. Okay. All right. So to continue, we're told that the water open this up. Okay, so we're told the water for desalting which is the wash water, is carried out at 3 to 10% of water. Okay, the volumetric flow rate of the water is about 5,000. Yes, 5,280 barrels per day. So I'm going to change this. My temperature was given, pressure was given actually. So we have the pressure of 450 psi. And then we have the temperature of 248 Fahrenheit. So okay, so from here we go to composition, and then we change the basis to liquid volume fraction, and then we make water 1. Click on OK. That is ready for us to do continue. So Okay, so from here the next thing we have is further heating. Now we're going to be adding 2 preheaters to it. Okay, I had adding another preheater because we have to heat it up. Call this preheater 2. Inlet is the wet warm blend. Energy here, I'm going to call this E2Q, and then outlets, I'm going to call this warm oil. Oh, okay. Before we get here, there is something we are supposed to do. Okay. Yeah, before we get here, something we're supposed to do. Now you know this is the combination of both crude oil and water, as well as you are also having gases in it. So we need to make use of the 3-phase separator to separate the 3 of them. Remember, our major aim is to get the oil. So we have the warm water blend, we have the gas coming out at the top. Liquid part, we have crude oil. Call this wet crude oil actually, because there's still water in it, a bit of water in it. Then we have effluent water. So with this that has been separated, then we just go into the heater. Let's do that again. So we have the wet crude going in. Remember we said this is E2Q. Then we have, let me say, warm crude oil. Okay, so for this we need to check the temperature. So the first heater in the simulation is heated the crude oil to 536 Fahrenheit. So I'm going to do this 536 Fahrenheit, and then the pressure, we assume there's no pressure drop. Keep it at that. The next thing is the second heater. Now this is going to be a fire heater. Alright, I'm going to have to change the icon because it was stated here the second. Okay, and the fired heater raised the temperature to 734. Alright, so I need to change this to the fire heater icon. So change icon, making use of this. So the warm crude is going in. I'm going to name this E3Q, and then my outlets, say to ATM to ATM. All right. Just put the temperature, which is given as 734 Fahrenheit, and then pressure still assume. Okay, let's just say we have 20% pressure drop. That's going to be 1.4. Okay. So with that, from here, all we just need to do is to go into the distillation tower properly. So like I said, this is going to be in 2 parts, and this is going to be part 1, and then we'll continue from here. All right, thank you very much.